In section 15C, we looked at how to find the volume of rectangular prisms. Now we're going to extend the idea to any prism. First of all, let's revise some of the terminology. A polyhedron is a solid bounded by polygons. Now that means that all faces are polygons. And a polygon, if you recall, is a flat, many-sided shape. A right prism is a polyhedron that has two congruent and parallel faces called the base and top, and all of its remaining faces are rectangles. One of the most important ideas here is that a prism has uniform cross-section. The word uniform here means that all cross-sections have the same area. This means that it's possible to take slices through the solid that are parallel to the base, knowing that the area of each slice is always the same. We're going to look at rectangular prisms and triangular prisms in particular. In a rectangular prism, the cross-section is always going to be a rectangle, which is shown in this diagram as a shaded blue rectangle. We can summarize these ideas on the diagram, noting once again that each slice is congruent with either the base or the top, and of course the base and top are also congruent to one another. It's also worth pointing out that by talking about a solid shape, we simply mean three-dimensional. The volume is given by the area of the base, or the area of any slice, multiplied by the height. We also need to consider a triangular prism, and the same ideas apply. In a triangular prism, the cross-section is always a triangle. We've redrawn the diagram with the base on the bottom, and we just need to remember that to find the area of a triangle, we use the formula half base times height, and once we have that area, we just multiply by the height of the prism and we will get the volume. Here's an example of a triangular prism, and we're going to calculate the volume. The rule is volume equals area times height. It's a good idea to label the base and the height that you're going to use on the diagram. Here I've chosen to make the base 7 centimeters and the height 8 centimeters. Remember that the height must always be perpendicular to the base. So the area is half base times height, which is 0.5 times 7 times 8, or 28. The units are centimeters squared, and the volume is given by area times height. Let's just mark 5 centimeters with H, and so we have 28 times 5 equals 140, and the units are centimeters cubed. It's a good idea to label your diagram to make sure you're correctly identifying which numbers to use in your formula. Now here's a slightly more complicated example. This solid is neither a rectangular prism or a triangular prism. It is a composite of both prisms. So one approach to finding the volume would be to find the volume of the triangular prism and then the volume of the rectangular prism and add them together. Now if we use this approach, we have the area of the base of the rectangular prism, which is 6 times 8, and we multiply that by the height, and that will give us 240 centimeters cubed. For the triangle, we have half base times height, which is half of 8 times 4. Once again, just labeling B and H on the diagram so there's no confusion. And we get 16 centimeters squared for the area of the triangle. Multiply that by the height of the prism, which is 5, for 80 centimeters cubed. And now we add those two volumes together to get the total of 320 cubic centimeters. Now I've gone through that fairly quickly because this probably isn't the easiest way to do these. So let's look at a shortcut. And the reason why this works is that prisms always have a uniform cross-section. So we can actually just find the area of one of the ends of this prism. So we're taking a vertical slice. Note that all vertical slices are congruent to one another. So we can find the volume by determining the area of the base and multiplying by the height. The area of the base is the area of the rectangle plus the area of the triangle. So I've written down the formula for that. And now we substitute the values and we get a total area of 64 centimeters squared. And now we just use V equals AH. Area times height will give us 320 cubic centimeters. I think this is the easiest way to do these problems. Just find the area of the base and then multiply by the height. It works for prisms because all slices or cross sections have the same area. One more important idea is that the base of a prism can be any polygon. If it's not a simple triangle or rectangle, the way to work out the area of the base is to divide it into triangles and work out the area of each triangle. To summarize, remember that prisms have uniform cross sections, and the volume of any prism is the area of the base or any slice multiplied by the height. Here's a selection of problems. You might find some of them quite challenging, but just apply the principles, use your diagrams, work carefully, and you should have good success.